This section is on page 254, and it's discussing what we call cation selectivity, and that just means that not all cations are treated the same or act the same in the soil. Some of them are more tightly adsorbed to the soil than others. Some of them have, it's kind of like a pecking order, so that if you had all of these cations in the soil at the same time, aluminum will be most tightly held to the soil. Lithium would be least tightly held to the soil. So there's some of them are common. We see commonly in the soil: calcium, magnesium, potassium. This one here is ammonium. This is sodium. That are all positively charged. You can see aluminum is the most strongly held cation on the surface of colloids. So in order to, so if we had a surface, let's say, of clay or a cation, a surface of a colloid, and you had aluminum on that surface, in order to displace that, in order to get that aluminum off, let's say we wanted to get it off, and we could only use, let's just limit ourselves to these here, you would need you couldn't just take calcium, obviously, because it's less tightly held. Calcium couldn't replace aluminum here easily. But if we had lots of calciums, okay, if we flooded this system with calciums, all of a sudden that the effect of all these together can actually remove or exchange aluminum off of those sites. So we kind of flood the system with something that's less tightly held, and we can actually get aluminum to come off. The same thing can be said for other things. If we had a bunch of magnesium on the exchange sites and we needed to get magnesium off, we might use something like potassium and flood the system with potassium and lots and lots of them to get that magnesium to come off. This is one way that we test soil. So if we want to find out what exactly is on this exchange site, we want to actually take things off, take everything that's on there off, and get it to come out of the solution, and we can measure that, the content of what's in that solution. So sometimes we use things like potassium chloride. We flood the system with potassium, and it kicks everything that's on there off into the solution, and then we measure what's in that solution. So that's one way we can look at this. This is also called the lyotropic series. Lyotropic series, and again, it describes how well or how tightly, or what the pecking order is of ions that are held on the soil surface. So we'll probably be referring back to this later on as we talk about soil fertility and things like that as well.